here we are. We're at Tuesday. Usually I do this on Monday, but you guys had that super serious test yesterday. So I thought we would wait until today. So yesterday we took our test. You do have parent surveys due on Friday if you want the extra credit. Lab equipment notes today. Tomorrow we're going to do a lab about how to read a graduating cylinder. Thursday is safety day. Big important day because, you know, this is a nice, dangerous class. Friday is how to light the Bunsen burner. One of the things about the Bunsen burners, some people love to light them, some people hate to light them, but safety says that by the first test, which is about 2 weeks from now, everybody in here will have to be able to light, adjust, and safely turn off the Bunsen burner. So I'm putting that on a test. You will never have to light it again if your partner likes to light it and you don't like to light it, but you have to show me you know how to light it, adjust it, and turn it off safely. Okay, so we're going to learn how to do that on Friday, so make sure you're here. Please don't wear extra copious amounts of hairspray that day. You will be sure to put, and while it's interesting, while it's burning, it's a no-no. And you will be pulling your hair back on that day as well, okay, and goggles and stuff like that. So, just so you know, that's what's coming up for the week. What I would also like to do here is I would like to go through this lab. I gave everybody a 10 out of 10 for doing the lab, so if you have it, flip it over. I saw a lot of things maybe I didn't agree with. So let's see kind of what you did and what you would, if you would have gotten them right if I was actually grading them. So why do you think it was important to scrub this down with steel wool first? Yeah.
How to get rid of the dirt.
You got it. Any impurities, if you will. You guys probably know that money is really dirty. So it might have oils, it might have oxidized, it might have a lot of stuff on it. In order to get a nice, clean, golden penny, you had to get as much of the impurities off both sides so that copper and the zinc can go together. Who thought that this was a physical change? Okay, nobody voted. Who thought it was a chemical change? All right, it's tough stuff. This is a really tough one because, and I would say it's an unfair test question. I wouldn't put anything this confusing on a test, but let's see. If you voted that it was a chemical change, can you tell me why you voted it was a chemical change? Yeah.
I thought they were fusing together.
Okay, so they're fusing together. Sometimes, what was the number one thing that you saw when you went from here to here? Yeah, perfect, okay? A lot of times when you see a color change, that means it's a chemical change, and a lot of people are saying you can't undo it. If you voted for a physical change, why did you vote for a physical change? Is it still a penny? Didn't change that. Okay, and to be honest, and I know this is why it's so confusing, if I had to choose one, I would choose physical change because it's a mixture, and mixtures can be undone. Now, it would be very tough, but zinc and copper do have slightly different melting points, and you could get these back apart, so you could undo it. So this isn't really all the way true, but you would destroy the penny. So I don't know. This one's a tough question. I wouldn't put anything like that on the test. I just wanted to see where you were thinking. Okay? All right. So why do you think you had to heat the penny in step 7? So we had the penny here, and that's copper, and then we put zinc all along the sides. Woo. Why do you think we had to heat it? I'm okay. To turn it into, so we're doing 7, which when you put it directly back on the hot plate. Are the solid zinc and the solid copper going to mix at room temperature? What did you need to do in order to get them to mix together? You had to melt them and heat them. Perfect. So you melted the copper and the zinc just enough so that they made the brass. Yes? Number 4 was all answered in the paragraph above it. If you could read that part, you said a mixture of metals is what an alloy is. This alloy is brass, and it's made with zinc and copper. These next 3 questions are my favorite. So with this in mind, would I be able to make a golden quarter? Why? What? Okay, good. So in order to make brass, which is this color, you need zinc and copper. Is a quarter made of copper? What's a quarter made of? Nickel, yeah, something silver. Okay, so you can't make 2 silver things turn gold because you needed copper and zinc in order to make the brass. That one's gold. Okay. If I cut this penny in half, would I see it gold on the inside? Why not? Perfect, yeah. Did we put zinc in it? Did we like mix it all up and make it? No, we just did it on the outside. It was an outside surface type thing. So if I went ahead and cut it in half, you're just going to see the surface level, okay, but it won't be gold all the way through. And then my last, this is my favorite. If I took the mass, and they have to be in the same year because pennies have different masses in some different years, But if I took the mass of my copper penny and then I took the mass of my golden penny, would they be the same? Why? Yeah. We added zinc. So even though it might not be a lot, the zinc that I added on there, does that have mass? Yes, it does. So this mass did what it went. Oh, good job. Very nice. So look at your answers. If you kind of did everything that we just went over, kudos to you. Very nice. Like I said, I did it for completion. Some of the things I was like, oh, no doubt, but just so I like to go over and make sure you're feeling good. Okay? Yes? Awesome. So what we're going to do, you can put that away. That's all done. What we're going to do is we're going to talk a little bit about lab equipment here. And what we're going to do is I'm going to give you a little piece of paper, and you can write all over this one, and you're going to work with your partner for the first half. I want you to write all over this. I want you to try to guess the name and the use. So I'm going to give you a few minutes, and then I'll give you a fresh copy to have for your notes, because I know that this will get confusing. All right, so number 1, beaker tongs. Hold hot beakers. Number 2, that you didn't know. Crucible tongs holds hot crucibles. We are going to get to crucibles. The crucible is right down there in number 8. Promise we're going to talk about it. So the crucibles, then you're going to use your crucible tongs. You want to keep the horns, hook them horns up, and here's the crucible right here. And then you grab it and it kind of settles right into this little nook. There's your crucible tong to hold hot crucibles. Okay. All right, so the next one is an Honors Chem special. Only Honors Chemists are going to use these here. This is called a burette clamp. Burette clamp. I got an example right up here. This is the clamp portion, and so I mean, I will probably not put burette clamp on the test because it just holds the burette. So all you want to do is say it holds that. Okay. And I do like to put beaker tongs and crucible tongs on the test because people confuse those. So just so you know. But what the burette clamp does is it holds the burette. The burette here is number 4. The burette. And a burette, if you can think about it, is an extra precise graduated cylinder. So what the burette is going to do is it measures exact volumes. Exact volumes of liquids. We will drag these bad boys out when we are doing titrations, when we're doing things we needed to know the exact volume. And the way that this works is you take your Erlenmeyer and you put it under there, and then you can see where you start. So we're starting at about 34 milliliters. You then open the burette, and the liquid will then fall out. You had one of these on your test yesterday, so I don't know if you knew how to read these or not by then. And then you stopped, and if we started at 35 milliliters and we ended at 40 milliliters, you know that 5 milliliters have fallen into your Erlenmeyer. Okay? So, burette, very, very precise volume measuring. What is the unit for volume when you're talking about a liquid? Does anybody know? Milliliter or liters. Liters is probably the base standard, but we're talking milliliters here. Okay? So this is a burette. Yes. Perfect. All right, the next one. Everybody knows the name, but I get nervous when we talk about the use. This is a Bunsen burner. And what is the B is capitalized because it's his last name, the guy that made this. Bunsen burner. What is this used for? Heating things. Thank you. People like burning things. Like step 4 is not going to be like burn the chemicals. It's going to say heat. So we're using this to heat things. Bunsen burner. Heating things.
Second round of that.
Yeah, I could. I'll try that one. I like that one. I like this one. All right. Next one. I do like Erlenmeyer on there. What's this guy's name? This is called an Erlenmeyer flask. The reason why I like this one, number 1, because you can't spell it. No, I'm just kidding. I'm terrible at spelling too. So even if you tried, if you couldn't really write the name properly, as long as you tried, Erlenmeyer, ERLENMEYER. That's his flask also. Like if you're, if you're cool and you create something, you could name it after yourself, like a Bay flask, but nobody wants to use that. That's fine. Okay, an Erlenmeyer flask is a very precise use, and I like to put this one on the test too. Unlike a beaker, where if you're trying to like mix stuff, it's all gonna slosh out. Erlenmeyers are actually used for mixing because the neck will pinch in. You can mix, you can swirl, you can do all kinds of kind of joining. So if you have something that's really hard to dissolve, you'll use an Erlenmeyer. So I'll definitely say used for mixing. There are incrementations down the side of these, but you never use this for measuring. Never. Okay? I wish they would even put those increments on there because then people pretend like they can do it. Also, the size of any glassware is the number written over the shape on the side. So this is a 250 milliliter Erlenmeyer. Mixing, not measuring. Yes. All right, next one. It's called a clay triangle. Clay triangle. Again, we're talking about these crucibles you haven't even met yet, but that's all right. Here is the clay triangle. It will be broken. This one is in your glassware drawer. That's why this one is on this sheet or in your hardware drawer. When you need to heat a crucible. So the clay triangle supports a crucible for heating. So if we, here, whenever we're heating a crucible, clay triangle supports the crucible for heating. Supports crucible for heating. Now we're finally there to the crucible. You can say crucible and lid, crucible and cover, whatever you want to say here. Crucibles. We have two types of crucibles. There is one that's metal that can't break, and there's one that's ceramic that breaks if you look at it wrong. So the ones that are ceramic have lids. If we needed to make the heat even more intense than the top there, we have a lid. And basically you use these to heat dry chemicals. Heat dry chemicals. Dry chems. Okay, you're heating dry chemicals in these. If you're heating liquids, you could probably just use a beaker, but dry chemicals need a special layer here. We're doing that. Crucible and lid heats dry chemicals. Hey, yeah, I can put that one on there. I can put that one on there. Depends on how I feel. The day of. All right, so funnel. Yes? What does a funnel do? Funnels thing. Yeah, you know, it's really tough. So whatever you want to say for a funnel, transfer, I think on my notes I wrote aids in the transfer of solids and liquids, or helps transfer solids and liquids. We have a liquid funnel that has a longer stem and a powder funnel that has a shorter stem. Okay, so if you're trying to pour into an Erlenmeyer here, it's nice just to have that so you don't spill. If you want to try to put powders in a test tube, you use a funnel so again you don't spill. Talk to me. For the funnel, let's say helps transfer materials, whether it be solids or liquids. I probably won't put that one on the test because it's such a vague thing, but you need to know what a funnel is because you'll use them this year. All right, here we go. What's number 10? What did they do? Protect your eyes. Goggles. We'll talk more on safety day about the different types of goggles. I do want you to keep in mind that sometimes you don't only need protection from splash. You also need protection from fume. So these ones that suction to your face, albeit you don't like them, are going to help and not let fumes get up into your eyes as well. Okay? Awesome. I don't know what they use in the biology. Do they use these or do they use the ones with the little like glass and then the black tip here? We call these pipettes. Some people call them eyedroppers, depending on how you're feeling. Pipette. How would you explain what a pipette does? Transfers small amounts of liquids, maybe? Transfers, yeah, you're going to use it when you're measuring, but it transfers them. Transfers small volumes of liquid. We're going to talk about this more tomorrow, but what always breaks my heart, if you need like 25 milliliters or something, and somebody's like, okay, we're just going to pipette our way there. 1 milliliter, 2. This is going to take forever. So you don't have to necessarily only use it. So if you're up here and you're trying to get some solution, you can pour it until you get close to 25. And then you're at the end, you're here, you're trying to get, and we'll talk tomorrow, you should be eye level, blah, blah, blah. But then you just use this when you're trying to do a more amount. Okay? Beautiful. So transfer small volumes of liquids. Number 12. Does anybody know the name of these things here? It's a mortar and a pestle. Yes, mortar and a pestle. Does anybody know what we use these for? Brine, crushing solids, things like that. You will have a lab where you have to take aspirin and grind them up, things like that. You don't like Freddy Krueger the goodness out of it here. You push and you twist and you push and you twist. But it will grind solids into a powder or crush solids into a powder. Wonderful.
Is that going to be on the test?
I don't usually put that one on the test. We only use it like once or twice a year. I would just know what it is. All right, 13. It's hard to tell on the piece of paper. It looks like a little like plate. This is actually called a watch glass. A watch glass. And the watch glass just holds reactions. And I kind of shorten reactions into RXNs.
They're on the test.
Maybe not a watch glass. I think we only use these once or twice too. Okay. Watch glass. Watch glass. Holds reactions. When you synthesize salt, you're going to make sure you use this because it would be too hot to have it in a test tube. Number 14, also hard to tell by the picture. Where did you go? Where are you? Ah. Stirring rod. Very good. Stirring rod. What do you think it does? Stirs. Get crazy. Stirring rod. Stirs. These are glass, so just be kind of careful. We also ask that you do not keep these in your drawers, because you throw it in your drawer and you slam your drawer shut and you're going to break it, and then shrapnel all in there. It's like a little shank, and you know when it's broken, so we don't do that. If it does break down and get sharp, let me know. I can always melt it down. Also, because they're glass, please don't like put them down and be like, I wonder if that will roll off, because yes, it will. So kind of put them perpendicular to wherever. Just be careful because they are glass and we don't want you to hurt yourself. They stir. Stirring rod. What's this next one? Test tube. Test tubes look cool. Okay, and all they're here to do is hold reactions as well. Okay, what you never want to do, and you act like it hasn't been done before, is you never want to act like you're just going to come on up here and use it to measure. Okay, you bring your test tube up and order, it's like, get 10 mils of copper sulfate. You're like, yep, looks good. No, there's no incrementation. So whenever you're going to measure into here, you always need a graduated cylinder before you put it into your test tube. So never for measuring. I don't even know how you could pretend to try to measure out of there, but you would be surprised. If you're going to measure anything liquid-wise in this class, you're going to use number 16. What is number 16? It's so smart, it's already graduated. Graduated cylinder. What does a graduated cylinder measure? Liquids what? You got it. Very nice. Liquid volume. And the unit for liquid volume is mLs. Liters, milliliters, all that kind of good stuff. Beautiful. All right, after that break, we have an evaporating dish. Guess what's going to happen in here? Some evaporating. What do you do when you're evaporating? Like if I have salt water in here, this will then drive off. I would say this would separate, let's just call that, separate solids and liquids. Okay? Separates solids and liquids. The evaporating dish. If you had salt water in it, the water would drive off and the salt would stay behind. Number 18 is the portion just up here. It's called a ring stand and clamp. Ring stand and clamp. Ring stand and clamp. All I would say for this is support for heating. Okay. we're going to learn on Friday, this is called the standard apparatus. You're going to put a Bunsen burner here. This is holding all this stuff up. Support for heating. The ring stand holds up everything while you're heating. Are we feeling good? Support for heating. I probably wouldn't put that one on there, but know what it's called. Ring stand and clamp support for heating.
So would you put 17 on there?
Maybe. I'd like the graduated cylinder on there better though. All right. Let's do it. On the back, 19, I would put this one on there. Like that one. People don't know what it's for. This is called a wire gauze. One, because it's wire, and two, because it looks kind of like meshy, like gauze. This has two functions. People will be like, oh, look, you just put it there to support during heating. But the main thing is, if I did not have this while I was heating, okay, the Bunsen burner would have a large amount of heat just directly here into the beaker. So what this does is this diffuses or spreads out, or however you want to say that, it spreads out the heat for even heating, or aids in even heating. The big thing here is that you know that it helps even out the heat. Even heating. Okay, the heat, and when we practice with the Bunsen burners, you'll see it heats it up nice and red in a nice little circle that's right underneath there, so it spreads or diffuses the heating for even heating. 21, I think it said, or 20, I think it said tweezers on the sheet I just showed you, but forceps, I think that's what Mr. Bracken calls them now, the AP teacher. So forceps, what do forceps do? They touch things that you shouldn't touch. It touches caustic materials, touches dangerous materials, something like that. Probably wouldn't put them on the test, but you should know what they are when we're using them. Forceps. 21, here we go. This is called a wash bottle. This one's a good one to have on there. You're like, woo, it's a chemistry squirt gun. And like, no, it's not really. Okay, what this is going to be is if you were trying to, let's say, oh, I don't know. Oh, if we were making a precipitate, or if we were doing something, you can see there's a bunch of green kind of left in the bottom here. What a wash bottle is for is it's to rinse glassware. So if I know I have chemical in there that I need to get out, I simply rinse like this, and then now I'm getting the rest of my chemical out. So I'd say rinses glassware. Beautiful. Now I know that every little chemical that I was needing in there is all out. Rinses glassware for the wash bottle. All right. 22 is not the Bunsen or the test tube again, but this lovely little guy. This is your test tube holder or test tube clamp, whatever you want to say. It's not exactly a tong because it stays shut. Any guesses on what this does? Holds hot test tubes. Good. So usually when they're warming, if you're taking them out of a hot water bath, if you're going to light a gas that's been caught inside and you don't want to hold it just in case it explodes and you want to hold it kind of back here, there's lots of reasons why you would want to hold a test tube. Holds hot test tubes, holds test tubes. Good. 23, what is 23? That's a beaker. Beakers are just fancy for holding reactions again. It's just like the test tube holds reactions. What are you going to guess you're not going to do with this one as well? Even though there's incrementation, we're not going to use it to measure. Good. The only thing you measure is either a burette or a graduated cylinder. And the size, again, is the number on the side over the shape. So today when you're looking for your different sizes, make sure you take a look on the number on the side. 24, yeah. Make sure you know. Test tube holder, no, but beaker possibly. All right. Let's see. Utility clamp. A utility clamp goes on here, and what I would say for it is holds round instruments. Okay, so it can hold like, it can hold a thermometer, it can hold a test tube, it can hold anything that you need to that is round. Holds round instruments. Awesome. Perfect. Number 25, what do we think this is? Test tube rack. This one's easy, probably won't be on the test because all it does is hold test tubes. Good stuff. But you need to know it because it is in your drawer. Anything in your drawer, you should just know. So you can say the name of them. 26, what is that one? They used to look like this until we got into the advanced digital age here. Thermometer, very good. And what does a thermometer measure? Temperature, good. Measures temperature. Anybody know the units? In science, the unit is degree, good. Degrees Celsius. We're not a Fahrenheit world here. Okay, we're a Celsius world. Perfect. So you guys will have digital now, which is actually really, really nice because you can just read it right off the screen. The last two, this is called a test tube brush. Okay, people want to know where they are because they act like they don't know where they are. They're hanging up in front of all of the sinks. And don't get it twisted. It can clean test tubes. It can clean beakers. It can clean Erlenmeyers. This is a really nice, I would call it a glassware cleaner. Cleans glassware because you can use it to clean beakers, test tubes, anything. Anything that's glass. I like that one because I want people to be able to use that. And then last but not least is a scoopula and a spatula. Those probably won't be on there because sometimes we just use spoons. But if you go to AP Chem, I want you to know the difference. This is a scoopula, scooping small amount of solids. A spatula is a little more flat. Okay, again, this is the pipette of the solid material world. It transfers small amounts of material. Transfers small amounts of material. Okay? Do we have any questions on any of the ones that we went over? Did I go too fast? Things like that. Another thing, if you want to check if you think you missed anything, I'm going to upload this lecture and my key, my own personal key that I have of all of these. I will upload that online as well if you wanted to check it. Okay? All right, we can pause this.